Welcome to this video lecture on the subject Basic Electrical and Electronic Circuits. In this lecture, we are going to discuss about nodal analysis. So what is meant by nodal analysis? So it is a circuit analysis technique to determine the voltage at various nodes. So once the node voltages are known, branch currents can be calculated. Basic principle of nodal analysis is Kirchhoff's current law. Algebraic sum of currents leaving or entering a node is 0. Steps in nodal analysis. So for the given circuit, we need to identify all the nodes in the circuit. So this is the first step. For example, in this diagram, node 1, node 2 are marked as V1 and V2. So the assign node voltages to the remaining nodes with respect to ground. So the reference node is chosen as ground, which is 0 volt. So remaining nodes are chosen with respect to ground. So in this diagram, V1, V2 are the primary nodes. And apply KCL at each non-reference node. For the V1, V2, we need to apply KCL and form the simultaneous equations. So these two KCL equations can be solved to obtain the node voltages. For the given current source, it can be directly included in the KCL equations, and we need to consider the direction of current while writing the KCL equation. Let's see the example for nodal analysis. So determine the current flowing left to right through the 15 ohm resistor. So for this given circuit diagram, we need to find the current I. For this, we need to write the KCL equation. So node 1 is marked as V1 and node 2 is marked as V2. For this node 1, write KCL equation. So we obtain 5V1 minus 2V2 equal to 60, and second equation minus V1 plus 4V2 equal to 60. So these two equations can be solved and we obtain V1 equal to 20 volt and V2 equal to 20 volt. So for finding the current through the 15 ohm resistor, here the difference between V1 V2 becomes 0, so the current becomes 0. Nodal analysis example 2. So take this circuit diagram, determine the nodal voltages as referenced to the bottom node. So first of all, we need to mark the nodes as V1, V2 and V3, and this circuit can be redrawn for clarity to identify the two relevant nodes for the 4 ohm resistor. And by applying the KCL equation for node 1, there are two entering currents minus 8 and minus 3, and V1 minus V2 divided by V3 is the leaving current and V1 minus V3 divided by 4 is the leaving current. So this equation is solved for node 1, and for node 2 there is a current minus 3 ampere and it is written as, it is in a direction, we need to consider the direction is opposite, so it becomes minus of minus 3, and for the remaining branches the KCL is written. And when solving these three equations, we obtain V1 and V2. So here Cramer's rule is applied, which is the matrix method. So we need to find the del V1 and del, and using the Cramer's rule we find V1, it becomes 5.4 volt, and V2 is equal to del V2 by del, so we find 7.7 volt. So V3 is del V3 divided by del, so it becomes 46.3 volt. So advantages of nodal analysis. This method is efficient for circuits with many current sources, requires fewer equations than mesh analysis in many cases. It is well suited for computer-based circuit analysis. Limitations of nodal analysis: it becomes complex with many voltage sources, and supernode handling requires extra care. Let's take the assessment. So what fundamental law is primary basis for nodal analysis? So here Kirchhoff's current law, so the answer is B. Nodal analysis generally used to determine which parameter? So it is voltage, so the answer is A. Thank you for listening this lecture.